Quantum mechanics is the branch of physics that describes the known behavior of matter and energy at the atomic and subatomic scales. It deals mainly with the extremely small, like atomic and subatomic particles. It works on the macroscopic level as well, but with a few exceptions, such as superconductors and superfluids, the results are usually the same as classical mechanics. It is, however, at the subatomic level that the differences between classical and quantum mechanics become significant. Quantum effects are classes of phenomenon with no counterpart in classical mechanics. Some of them are quantization, the uncertainty principle, wave-particle duality, quantum tunneling, quantum entanglement, and quantum teleportation. Quantization is the situation where physical quantities like position, energy, and momentum can have only certain discrete values. For a particle free in empty space, these physical quantities are continuous, but a particle bound to an area of space can only have certain discrete values. The uncertainty principle basically states that there is a limit on the accuracy of simultaneous measurement of physical quantities, like a particle's position and momentum. As a result, the more accurately one measures a particle's position, the less accurately one can measure its momentum, and vice versa. Wave-particle duality is the tendency for light and matter to exhibit the properties of both waves and particles. It is a key concept of quantum mechanics. Put another way, light and matter sometimes act like particles, exhibiting properties like scattering. Other times they act like waves, exhibiting properties like interference and diffraction. Quantum tunneling is related to wave-particle duality, in that it results from the wave nature of a particle. It is the process by which a particle gets across a barrier that it cannot classically pass. Now, the probability of an individual particle getting through the barrier drops exponentially with the thickness of the barrier. However, with a large number of particles, some will get through. Quantum entanglement is the phenomenon in which the quantum states of two or more objects have to be described with reference to each other, even though the individual objects may be separated in space, so that a change in one object causes an instantaneous change in the others. Here's an illustration. Bob and Jane become quantum entangled. Bob and Jane then become separated. Tim comes along and kicks Bob, and Jane says, "Ouch." Quantum teleportation is the transporting of a quantum mechanical state between two locations by way of an entangled state and some classical information such as light. The need to use classical information eliminates this as a potential faster-than-light communication method. There are several different interpretations of quantum mechanics. One is called consistent histories. In this view, quantum mechanics simply predicts the probabilities of various alternative histories. Next is the Copenhagen interpretation, which says that the only thing that matters are the experimental results. Now, while this is currently the most popular interpretation, it is losing ground. Next, we have the transactional interpretation, which sees quantum mechanical waves as standing waves in space-time, constructively interfering where the particle is and destructively interfering every place else. Next, we have the Bohm interpretation. In this view, the waves guide the particle. Now, while it is totally deterministic, it requires a large number of hidden variables, which cannot be directly measured. Next, we have the many worlds interpretation, which sees the world as constantly splitting off into multiple universes in which every possible quantum event actually occurs. The next view simply posits that consciousness collapses quantum mechanical waves. Finally, we have general intelligent design, which postulates that quantum mechanical waves and their collapse are a result of intelligent agents that determine the states resulting from the wave's collapse. These intelligent agents could be actual intelligent beings or mechanisms programmed by an intelligent being.